Now, without further ado, I'm excited to welcome AWS as our very first special guest speaker in today's Tech Deep Dive. As you might know, Carnegie has a strong and long-standing partnership with AWS. We are proud to be on the AWS marketplace, and we are also an AWS advanced and conversational AI competency partner. Not only we are on AWS Marketplace, but we also have a lot of mutual customers to expand our success. And the foundation of our partnership is actually their native integrations with a variety of AWS and Amazon services, as you might know. It goes way beyond hosting. And one of the highlights is that we are now providing native support for the latest generative AI capabilities from AWS, which is the Amazon Bedrock and Nova models. So today, I'm super excited to have John Musa, Senior Solution Architect from AWS, with us here to explore the potential of Amazon Nova for customers' experience and how you can maximize the winning Carnegie AWS partnership. Welcome, John.
Hello, everyone, and thanks for joining us today in our session about Amazon Nova and Bedrock. I'm John Musa. I'm a Senior Solutions Architect at AWS. I live in Düsseldorf, and for the past 5 years, I've been working with different kinds of customers. Enterprise ones, online retail customers coming from digital native backgrounds, and I've been also working worldwide with a lot of customers on their data strategy journey and how can they innovate with their data on machine learning platforms like traditional machine learning and generative AI. What we're going to talk about today is some of the innovations with Amazon Nova models, because we recently released some new models in reInvent. We're going to talk about Amazon Bedrock as a service that enables you to build your use cases on top of foundational model and large language models. And then we're going to do a story, a use case that I learned from one of my retail customers, and we're going to see how we're going to use the features that we have with Amazon Bedrock in order to solve this use case. All right. Nova is a class of foundation models that Amazon has been using at Amazon scale. And you can imagine at the scale we're using at Amazon, if you, for example, open your Amazon app, you're going to find a new assistant that's called Rufus. And Rufus is taking a lot of requests from millions of customers every day. On the other hand, at the scale of Amazon, we also have a lot of employees that want to have access to productivity tools. And this is the kind of challenges that we look at when we look at what kind of foundational models or things that we at Amazon invest in. We want to balance out performance, latency, and cost effectiveness. That's why we have Nova as maybe two categories of models. Models that are designed for understanding, where most of them are multimodal, except for micro, which is designed for text understanding. And then we have the generative or creative models that enables you to generate images, videos, and do great things with images, like with Nova Canvas, where you can remove background from your images. As I mentioned, all the models are multimodal except for micro, which is very cost-effective. And it shows basically on the understanding capabilities of those models. But you can also increase this understanding by doing fine-tuning of those models. And this is bringing the capabilities of those models closer to your business domain. Also, as we increase from micro to light to pro, we also increase the context size. And this is important because this is the amount of information so that you can give the model up front to be intelligent about its responses. We're going to discuss some of those things. Why do you need them for this bigger context? Premiere is coming soon, so stay tuned. And it should be the highest understanding model. Right. But you might think, OK, so fine-tuning. Am I going to take care of infrastructure and fine-tuning and doing things on my own, right, and scalability? Well, that's why we have Amazon Bedrock. Bedrock is a class of services and features that help you interact with the foundational models and large language models that we have at AWS in a scalable and secure way. Those features include things like prompt management and also putting guardrails so that people do not misuse your large language model. But they also go way further than that, and we're going to discuss some of those features throughout the use case or the stories that we're going to have. And Bedrock also does something very interesting. Instead of you having to learn how to interact with all those models, Bedrock gives a single pane of glass where you can just use one API to interact with all those models. These include models from Amazon, of course, just like we mentioned with Nova, but they also include our partnership with Anthropic and the latest Claude models, where with Amazon and AWS, this is the only place where you can fine-tune Claude models. It also extends to some of the open source models, like Llama from Meta, and you can also use models from Mistral as well. We also opened, as the last reInvent, a marketplace for the models, where you can even bring in your own foundation model if you think that you have fine-tuned something which is interesting for others. And this is a reason why we were able to bring in DeepSeek with Amazon Bedrock 1 week after it was launched, because it was an open source model. And there you can just interact with it without having to learn about how to deploy DeepSeek on your own or something like that. You can just interact with it through the single pane of glass that we provide with Bedrock. It seems that Clicker is a little bit picky. OK, but now it's time for our story time, right? I previously used these characters in some of my stories. But today, since we're talking about generative AI, so we can get a little bit more creative, right? So these characters got an overhaul. We have Buzz from Business, whose image was generated by Nova Canvas. And Buzz represents a person who's going to provide us with all the business requirements and problems and how he can measure KPI progress. We also have Sandra, the data scientist. She's the one that takes like whatever Buzz says, tries to figure out what would be the intelligent way to think about things, right? And we have Jim, data engineer or data architect. Jim is helping out Sandra access the data that she needs and provides her with all the tooling, orchestration that she might need to get her job done. Who of the audience would identify themselves with Buzz? Do you have anyone here? Is it? Right, very few people. So we can make some jokes about Buzz. Sandra? Anyone here is a data scientist? OK, some people. And Jim? All right, OK. And any of you, by any way, use AWS? All right, some people, great stuff. All right, sorry. Buzz was asking everyone, hey, I want some way to handle problematic customers that we have. By problematic, he means that customers that had issues, because those are customers that are likely to churn away. And those are very hard customers to deal with. Also, the way that we have been dealing with them is not consistent. Sometimes we provide them great service, sometimes we provide them not so great service, so we want to have some kind of a consistent way to deal with those problematic customers, because that's like very sensitive customers. All right, so Sandra gets into action and starts asking, okay, what are those problematic customers? And we're going to imagine we're now in a retailer, right, an online retailer, and we have one of those customers, Helen. Helen comes in and asks, where is my order? Now, in order to try to answer Helen's question, we could just answer and say, Helen, your order is lost, or Helen, your order is with a carrier. This is it, right? That's the answer that we might think Helen needs. But Buzz has an interesting idea. He says, okay, what if we try to understand what's Helen's situation, assess based on that if we need to provide her some promotional code or something to help her not churn if she's in a bad situation, and then provide those promotional codes to her. That would be a great customer experience for Helen. So Sandra starts to come into action and says, okay, you know what? I know how to improve chatbots and large language models. There are a lot of techniques that can help us do that. And this starts with prompt engineering. Prompt engineering is you being clever and telling the model how it might solve a problem. One example of those is chain of thought. If you think that there is a problem that's very logical and very hard to solve by a large language model on its own, what you can do is put an example of this problem and say, if I would solve this problem, these are the steps that I would do to solve this problem. And then tell the model, now this is my actual problem. How can you solve it? And then the model would interestingly solve it and even provide some steps of how it went through by that, right? Another technique would be RAG, Retrieval Augmented Generation. You might have heard the word a lot, but what it basically means is that we want to fill in the context, the initial context, not by ways to solve a problem, but rather by initial information that the model can use to try to solve the problem. This can come from your own policies or your own data or something like to make the model context aware about the current situation. Some other techniques like fine-tuning or continued pre-training, but those are very advanced things that you need to do with your large language model and foundational models. Let's leave those for some other time, right? All right, so how does retrieval augmented generation work? Well, Sandra describes it in a very easy way for Jim. She says, on one side, we're going to bring in our documents or company policy about how to handle customers that have troubles. Once we do that, we're going to use something called an embedding model. An embedding model is just going to turn our text into numbers, because that's what machine learning models do, right? They want to interact with those text as numbers, right? We call them vectors. We store that in something called a vector database. Now, once a question comes in, what we're going to do is that we're going to use another model, understand the intent of the question, and extracts for us some keywords. Since we have some numbers that we can extract out of those keywords, and we have some numbers embedded in those vector databases, we can then say, okay, what is near, like how are those numbers related to each other? And this is what we do with the vector databases. They tell us how those vectors are near each other in a very high multi-dimensional space. So we bring in the relevant documents and text from our policies to the large language model, and we pre-fill the context with that information. And say to the model, you have the question, this was the context, this was the search results that we did, now try to answer it. And this provides, for us, the very first place where we can understand the context about what happened or how can we handle certain troubled customers. Now you might say, okay, should I, am I going to build the whole thing? Well, the answer is no, because you can use Amazon Bedrock knowledge bases, where all what you need to do is specify a data source of your documents, whether that's your object storage or S3 or whatever, right? And then from the other side, just say, I want a model for embeddings and I want a model for reasoning. And then you can just start chatting with your documents. You don't have to care about the vector database because we can provision that for you. If you have a preferred vector database, we can also use that instead of the ones that Bedrock can provision that for you. All right. Now we understand policies and we can assess, for the case of Helen, what do we do with it, right? But we need to know how are Helen orders doing. So Sandra becomes intelligent and tells Jim, you know what? Let's do exactly the same thing, right? Let's make all Helen's order, like export them as PDFs or documents and connect them to knowledge bases. And then Jim says, like, no, we cannot do that. We have hundreds of thousands, if not millions of customers. We cannot do that for all those orders. We need something more intelligent. That's why knowledge base can interact with your structured databases, right? So it can go into a Redshift and then tell Redshift, I don't need everything that you have. We are going to use a model to understand the schema and everything inside Redshift. And Redshift is going to help us ingest not just structured data, but also semi-structured data, because it connects to your whole lakehouse architecture. So it connects to all the data that you have in your data lake. And it understands how to query this data. So you don't have to care about that. And then we're going to use a model to say, this is a request. Now you understand the intent, right? So generate an SQL where Redshift can bring in the relevant records to help solve the initial questions that we got, right? And this is what it really does. It uses Nova, generates an SQL, you bring in the data, right? And you use this data to generate a response, because you can use another model to generate the response for you. Once you do that, now you have filled the context of your large language model. Okay, so those are two pieces of the puzzle. Now we know Helen's order history, and now we know what is the policy for certain, like, I don't know, customers, and we can also set the tone of our bot. But how do we actually apply promotion codes or things like that? Because this would need that we would interact with our CRM or other APIs, and this is what you can do with Amazon Bedrock agents. With agents, you can actually provide multiple actions and say what is the intent of every single action and how to extract the parameters that you need to execute every one of those actions. Those actions can be API calls or even calls to other Bedrock knowledge bases. So it can be a lot of things. And you are very flexible. You can even write a code about the actions that you want to perform with AWS Lambda functions. By the way, so far we have not provisioned any server, right? So we're not managing anything on our own so far. And this is what the agent will do. It's going to continue to talk to the actions step by step as you have defined the flow for the agent until it tries to solve the problem and provides additional information to the context. So agents also do not let you figure out what happened in between. They are very traceable. You can just tell the agent, all right, I provide you a query, I got a response at the end. What happened? What were the steps that happened in between? And it's going to tell me, well, for the first step, I went to this kind of action, I received this response, and I generated out of this response this text to pre-fill the context and continue the flow with the agent. So you can trace exactly what the agent is doing for traceability and debugging. All right. So now we have some actions. We can apply some promotion codes to Helen. But how are we going to orchestrate all of that? Again, you can use Bedrock flows, which is a visual way where you can bring in all those pieces together and try to apply Buzz's thinking into a visual canvas and see how you can go from like an initial question or intent from Helen to a final response to her. This is what it might look like. Where's my orders? Now we can tell Helen, we're sorry. We see that the last 3 orders were delayed. Because this is something that we can get out of her order history. They were always delayed. The order from last week is going to come to you, like there is a courier. We see a status and a courier and a tracking number that you can use. But now we can set an apologetic tone for our agent. And the chatbot can then say, we apologize, and we would like to apply for you a 5% promotional code on your next purchase because of the troubles that you've had. Now, that's a way to try to retain Helen, right? And hopefully, we turned Helen from a sad Helen here to a happy Helen. All right, so to summarize, Bedrock simplifies for you how you interact with large language models. If you look at our stack of what we call the generative AI stack with AWS, we have on the very top layer services that you don't need to learn anything about large language models, and you can just interact with them directly. Like, for example, Amazon Q, where if it interacts with your QuickSight, which is a business intelligence tool, you can just ask it questions from your data and tell it to build visualization and business intelligence dashboards and reports for you automatically from your natural language questions. In the middle layer, we have Bedrock. It simplifies for you all the scalability and all the guardrails and security and responsible AI concerns that you have when you're interacting with large language models. Also, you don't need to learn about how you're going to interact with every one of those large language models. And on the bottom layer, you can, of course, use the AWS host of machine types that are optimized for training and inference to also fine-tune your own models or bring in your own open-source large language models. Bedrock can be also found in a region near you. It's all around Europe, right? You can start using it in Frankfurt today. And if you want to also get your hands on with something that AWS provides, you can just go for AWS Party Rock and start getting your first taste of how do you generate your first generative AI applications that can maybe help you with the productivity tasks that you have. What's coming for next? We're not going to stop here, right? We're going to innovate with Nova even more, so expect that Nova is going to be having a capability of speech-to-speech and also any-to-any, where you can provide a text or speech, and then you can determine how it responds to those prompts. With that, I'd like to thank you all for coming here. You can find my social media accounts if you want to connect or deep dive about any of those topics. Additionally, if you have any questions or anything, please come back, right? I'm going to be staying here. And also, if you want to accelerate this journey further, you can connect to any of the Cognigy people. Anyone here? Can you raise your hands? Yeah, maybe people at the back, I don't see. All right, but you can connect with them to accelerate your journey with larger language models on AWS and agentic workflows. New?
Thank you so much, John. Thank you so much for such